Jai Hind children. I welcome you all in today's live class of chemistry. Children, remember that in our previous class, I have explained you some of the topics of the chapter, that is elements, compounds and mixture. Now, today I will start the next topic of the chapter, that is symbol. Now, children, before starting the topic symbol, I want to discuss the oral questions which are given in your book. So come to the first oral question, and after that we will discuss the symbols. So the question number one, which is given in oral question in your book on page number 28, is what is the difference between the smallest particle of an element and the smallest particle of a compound. So children, remember that I have explained to you that about elements and compounds, and also I have explained you about the atoms and molecules. So remember, atoms are the smallest particles by which the elements are made up, and the compounds are made up of by the smallest particle, that is molecules. So here you can see that the elements have the smallest particle atoms, whereas the compounds have the smallest particle, that is molecules. Now the question number two is, for all elements, the smallest particle that can exist independently is an atom. Do you agree? So, children, it's given that for all atom or elements, the smallest particle that can exist independently is atom. So, it's no, not for all element, because some of the elements are found in combined state and their atoms cannot found independently, cannot present independently. They are always found in combined form, like oxygen. Oxygen is the gas which is found always in the combined form, that is, the two atoms of oxygen get joined together to make one molecule of oxygen. So you can say that all elements are not, they have the smallest particle atoms which exist independently, because some of the elements are existing in combined form. Now, the question number three is, most elements are found in free state in nature. Do you agree? Give reason. So, children, most of the elements are found in free state. Just think about that. It's not like that. A few elements are found in free state, whereas the most elements are found in combined state, because they are always going to join with the atoms of other element. So they are found in combined state or in the form of compounds. So we can say that a few elements are found in independently, they exist, are living free in nature, whereas most of the elements are found in combined state. Question number four is, a scientist found that two samples of the same compound had the same elements combined in different ratios. Was the finding correct? So, children, please go through the question properly and read it again. It's given there, a scientist who have found that the two samples of the same compound had the same element combined in different ratio. No, it's never, because the same compound will not found in different ratio. The same kind of compound which are made up of same element, they will always found in the same ratio. So this finding was not correct. Now the question number 5, the same scientist as ever found that the two samples of a mixture of the same element had the elements mixed in different ratio. Was the finding correct this time? So this time you can say that the finding can be correct. The finding is correct because the two different elements are more than two different elements. When going to mix in different ratio, they are going to react chemically with different ratio. They form the different kind of compounds. So this is possible. But it is not possible that the same compound can be found in different ratio. So here in this answer, you can write that yes, this statement is correct. Now, children, I hope that you understood all the answers of oral question. So try to write the answers first in your rough copy today. Now, come to the topic that is symbol, which will start today. Children, as you already have studied in your language of chemistry, that there are number of elements are found and approximately 118 elements are known, and these all elements have their particular name like carbon, oxygen, hydrogen, and so on. And there are number of compounds also, and they also have the particular names like copper sulfate, ammonium hydroxide, and so on. There are number of elements and number of compounds which we are using, which we are studying, which we are writing. If we will use their complete name to write, so it's very difficult to write them properly. And that is why scientists have developed, the people have identified the requirement to show, to represent these different elements and the compounds not with their complete name, with their abbreviation or certain indications by which they can be indicated easily and shortly. So the symbols are those abbreviations which are used to represent the elements. But these symbols as we are using nowadays are not used as in previous time. In previous time, people are using different signs, different pictures to indicate the different kind of elements, because that time very few elements was discovered, so that is why it's easy to indicate them by using certain pictures or signs. But nowadays we have number of elements, so it's not possible to indicate them by using different pictures or symbol. So nowadays we have the method to indicate the different elements by using their letters, first letters of their name or first two letters of their name. As the carbon is indicated by capital C, oxygen indicated by O, and so on. So this method was suggested by the Berzelius. But before that, the different people have the different methods to represent the elements. So come about those signs and pictures which are used in earlier time to indicate different elements. This is the picture which is used to indicate common salt. This is the picture used to indicate the copper. Picture used to indicate iron. Picture which is used to indicate the element silver. And this is the picture which is used to indicate the gold. So these are certain examples of the pictures which are used in earlier time by the people to indicate or to represent the different substances, different elements, compounds, and all. But as the time passes, and it is not possible to denote all the elements by different pictures, the people have started the use of signs to show the different, to indicate the different kind of symbols. So I have here some of the signs which are used for different elements. This is the sign used to represent copper in a circle, capital C. To indicate iron in a circle, capital I. For silver, inside the circle, capital S. To indicate gold, inside the circle, capital G is there used as a sign for gold. To indicate hydrogen, the sign which is used is inside a circle, a dot mark. And the sign which is used to represent carbon is a dark circle. And this is the sign used to represent the oxygen. So these are some of the example of the signs which are used to denote the different elements in earlier time. But the Virgilius, a scientist who have suggested the modern method to indicate or to represent the different symbols by using the alphabets, and especially those alphabets are the first letter or first two letters of the English name or Latin name of those elements. So that method is termed as Virgilius method of symbol. So here we have some of the example. Carbon. The first letter of carbon, English name, capital C. So its symbol will be capital C. Hydrogen. The first letter of its name, that is H. So this is the symbol of hydrogen. Oxygen. The first letter, that is O. Sulfur. The first letter S. So these are some of the common example of the elements who have the symbols as the first letter of their English name. But one more thing you have to remember about the symbol. Some of the elements are here who have the common alphabet in their names as the carbon, that is C, starting from C, and cobalt. So we cannot use the first only letter to indicate them as a symbol because that capital C is already used to denote the carbon. So in such case, the first two letters are used to denote them as a symbol. So the symbol of cobalt will be CO. First letter will be in capital and the second letter will be in small. So CO is the symbol of cobalt. Helium. He. The first letter will be capital H and second letter will be small e. Neon. First letter will be capital N and second will be small e. So these are the symbols which are also used to denote some of the elements. Here we are going to use the two alphabets, first two alphabets of their English names, because by using only single alphabet it will make a great confusion, like the capital C for carbon and CO for cobalt. Just like that, capital N for nitrogen and Ne for neon, H for hydrogen and He for helium. Now the third thing, some of the elements, their symbols are given not by using their English name but by using their Latin name, like iron. Iron. The English name is iron, but its Latin name is ferrum, and that is why the symbol of iron is taken from its Latin name, not from its English name, and the symbol is Fe. Copper. English name of is copper, but its Latin name is cuprum, and that is why the symbol used for copper is Cu. C will be capital and U will be small, and so on. So I have given you here the three different ways by which we are going to denote the different elements. The first way is using the first letter of their English alphabet. Second way, using the first two letters of their English name. And the third one, using the Latin name of those elements. And these all are the symbols used to denote the all elements which are known, and that formula is also the indication or representation of the symbols in which the different elements which are found in those formula are used or denoted by using their symbol, like the formula of carbon dioxide. Here the two different elements carbon and oxygen is present in the ratio 1 is to 2. So it will be represented as, so in this formula of the compound, we are going to use the symbols of different elements which are present in this compound, carbon and hydrogen, in a ratio 1 is to 2. So this will be termed as the formula of the compound, and these will be termed as simply the symbols of element. So then I hope that you understood well about the symbols. Now come to the next topic of the, that is formula. As I already have explained you that the formula are the term used to denote the compounds, not for the elements. For elements, we already have used the term symbol. So formulas are the abbreviations, are the representations of the compounds which are made up from more than one different kinds of elements in a particular ratio, in a proper ratio. So those representation or those indications will simply termed as formula. I'm going to explain you with the help of some example. Hydrochloric acid. It is a compound and it is made up from two different elements, that is hydrogen and chlorine, and its formula will be HCl. H hydrogen and Cl is the symbol of chlorine. Iron sulfide. Children, remember that the symbol of iron is Fe, and the sulfur, that is S. So the formula of iron sulfide is FeS, because this compound is made up from these two elements, iron and sulfur, in the ratio 1 is to 1. The next example is magnesium chloride, and its formula is MgCl2. Mg, that indicate for magnesium, and Cl, that indicate for chlorine. So the magnesium chloride have the formula MgCl2 because here the ratio of these two elements are 1 is to 2. So that is why MgCl2 is the formula of magnesium chloride. Sodium oxide. The symbol of sodium is Na and the oxygen, that is O. So that formula of this compound is Na2O, because here the ratio of these two elements present to form the compound sodium oxide is 2 is to 1. So that is why it's written here Na2O is the formula of sodium oxide. Magnesium oxide, MgO, as magnesium symbol Mg and oxide symbol O. So this compound is having the formula MgO because these two elements are present in 1 is to 1 ratio. Carbon dioxide, that already I have explained. CO2, because it have the two different elements carbon and hydrogen in the ratio 1 is to 2. So this will be the formula of carbon dioxide. Methane. The formula of methane is CH4 because this compound is made up from the two different elements, that is carbon and hydrogen, and these two elements are in the ratio 1 is to 4. So the formula will be written here of methane as CH4. So these are some of the examples of formula of different compounds, and these all formulas are made up from the symbols of these elements which are present in these compounds, are that elements by which this compound is made up of. Now children, I have some more examples of the groups of chemicals like carbonate, the formula is CO3. Sulfate, its formula is SO4. Nitrate, its formula is NO3. Bicarbonate, its formula is HCO3. Hydroxide, its formula is OH. And ammonium, its formula is NH4. So these are also a kind of compound, but the name group word is used for them because they can again join with different elements to form a new compound. So that is why these compounds are termed as the groups. and they are termed as carbonate. The formula CO3 sulfate SO4, nitrate NO3, bicarbonate HCO3, hydroxide OH, and ammonium NH4. Just take the examples of some of the compounds which are formed by using these groups. When this carbonate group will get joined with sodium, it will form sodium carbonate NaCO3. When this sulfate group will join with copper, it will form the compound copper sulfate. When this copper will join with nitrate group, it will form copper nitrate. And the formula is CuNO3 whole twice. This whole twice indicate for that the ratio by which they both are present in compound copper nitrate, and that ratio is 1 is to 2. The group ammonium, when it's going to combine with chlorine, it forms the compound ammonium chloride, and the formula NH4Cl means that the one molecule of ammonium group will join with one element of chlorine to form one molecule of ammonium chloride. So, children, I hope that you understood the today's topic which I have explained. If you have any doubt regarding any topic, so you can ask your questions, your queries between 2:30 to 3. Thank you and have a nice day.